This is the solution to problem number 1 of the midterm for lab section 52. So you're given a geometry like that, and and of course it says that the left face ABCD is clamped, and then this right face EFGH is subjected to an upward force of 200 pounds, and the internal pressure on this bore is 200 psi. Okay, now you're asked to use the most appropriate element, and in all likelihood, 99% of you folks will use solid elements to do this, and that's great. That was really intention. However, there may be a few of you who decide to use shell elements here too, and this is okay. A shell of thickness 3 inches, a shell element is okay too, as long as you have done it uh, correctly, and you get the full 30 marks. Okay. Now, uh, you're asked to use all planes of symmetry because this is an upward force, and the loading and the restraint here. The only plane of symmetry that you have is cutting it like so. In other words, through the thickness like that, halfway through the thickness. Okay, but I'm going to model the whole thing and then cut it with some plane. Okay, if you want, you can model half of it as you're eventually end up doing. The other thing is that you're asked to use a local mesh around the hole. Okay, so I'm going to do that. Let's start with the part file. Let me start with the part file. Just 1 second. Okay, so let's start with the part file. And on a convenient plane, which is on that vertical plane for me, you make something that resembles that geometry, right? So there are different ways of doing it. So let me do it like this, okay? It's entirely up to you. So I'm going to make something like that, okay? And let me dimension these two also. This width is 15 inches, 15 inches. This height is 3. I'm going to add the circles in just a minute. This height is 3, okay? And then I'm going to add this circle here. The circle is centered at this line. Yep, let's say the inner circle. And then I make another one, the outer circle. There are different ways of doing this thing. So you do it the way you want, and then you do a cleanup. So let me use the quick trim, get rid of the stuff that I don't want. I don't want this. I don't want that. And not this. Oops. Try it again. I don't want this. Let me see. What are we doing here? Let me see for a second. Okay, it's not taking that. That's okay. So let's do it a different way. There's more than one way to skin a cat. Okay, so here, there, and oh yeah, I think I know what the problem was. Okay, I did not want to remove that middle thingy. Okay, that's okay. There's so many different ways of doing these problems. This is not closed. I have to. Maybe it is closed. I'm not sure. I'm gonna close it. Okay. I'm not sure if that it looks like closed. Okay. Oh, this was a full circle. Okay, no problem. So what I can do, I can say this, control that, close it up. I think you can close it up like that. Yep. Okay, let's put some dimensions here. The radius of this outer circle is 3, and the radius of the inner circle is, I believe, 2. Diameter 4. Is that right? Diameter 4? Yep. Yeah, that resembles like what I have. Exit and pad it by one and a half inches in each direction. This is nuts because I'm going to cut it in just a minute. That's okay. That's how I like to do it. All right. Now let's apply material and then we're going to split it. Okay, apply material on this steel, made out of steel, on that part. Say okay. And we're going to use the saw, split it with this middle plane. It doesn't matter which side we pick. And there we are. This is half of that thing. And let's save it. File, save management. Let's see, save as. I'm going to create a folder called Midterm Section 52 Problem 1. And already has something in there by that name. So I'm going to replace it. Okay, there we are. Good. Now we're done here. So we're going to go to generative structure analysis. CATIA automatically measures this thing with whatever type element that I had, whether it was linear or parabolic. We're not going to take off marks if you decide to use parabolic, but don't. I mean, we said use linear, so please use linear. There. Okay. The only thing I'm asking you to do is to have a finer mesh around the hole, and you know how to do that. You look at the model manager toolbar, and then the second toolbar from the left, if you look at it, there's these three things. The one in the middle, local mesh size. So you go and select the inside of that, and whatever number you have here is going to try to put the element that size around the hole. Okay, I had this point 2 because of the previous problem. Okay, good. Now we are told that this face is clamped. Okay, we are told that this face, the entire face, is pushed up by a force of 200, and since we're modeling only half of that, it's going to be 100 pounds up. The other side is 100, total of 200, but we're not modeling the other side. And we are told that the inside of this is subjected to a pressure of, I think, 200 psi. Don't divide 200 psi by 2, whatever. Select the entire face, 200 psi. Pressure is pressure. That's pretty much it. There's nothing else. So let's save the analysis, file, save management. This analysis in that same folder. Again, I already had something there by that name. That's okay. I'm going to overwrite it. And then okay. Now we're going to run it, make sure it works, and then once you run it, you submit your work, which means the part file and the analysis file, with the naming conditions that we gave you. I didn't do that. Your student ID number, your last name, and then problem number 1, right? And it goes to the folder in Blackboard, which says lab section 52. Yep, that's it. It works. There it is. You don't expect anything unusual. There we are. We don't expect you to give us these, but these are for you. And you can save you can show that the different rendering if you want for your own good. We don't need it. So that takes care of this. I'm going to stop the video here.